The last thing that we're going to talk about today, and we'll do several examples to practice this, is the fundamental theorem of algebra, which basically says that if we have a polynomial and it has degree n, then that means that it has n solutions. So if we have a quadratic, we know that a quadratic's degree is 2, so it must have 2 solutions. And we'll talk in a minute about what those solutions can look like. If we have a cubic function, then it has a degree of 3. And so we are expecting to see 3 solutions. Why don't you pause the video and do some rough sketches like I have showing these 3 different conditions. The thing that I want you to be sure of is that when you draw this one that's in blue, that you can get 2 dots on the x-axis. This one comes and touches the x-axis but doesn't cross it, and this one's floating above. And then similarly over here, make sure that you are matching the way that I've got dots, either 3, 2, or 1, depending on which graph. Come back here when you're done. Okay, so let's talk about the types of solutions that we could expect for a quadratic. So we have a degree of 2. We know we have to overall have 2 solutions. So if we look at the blue right here, I can physically see 2 dots, 2 places where I cross the x-axis, so that is 2 real solutions. So you can say 2 real, and if you want to in parentheses say that that's x-intercepts, because we can physically see those 2 x-intercepts. On the pink one, I only see 1 dot, but we learned that if we come down to the x-axis and we bounce, that means that it was a repeated solution, an RS. And so let's make a note about that. So even though I only see 1 dot, the 1 dot that I have is an RS, a repeated solution, or a bounce. So that counts twice, so I have 2 real solutions total. Finally, the third thing that I could have is I could have a graph that never touches the x-axis at all, like this green one. And in that case, I can't physically see any x-intercepts, so that means that I have 2 imaginary solutions. They are in a different plane, so it's 2 imaginary solutions. Let's look at our cubic now. We're going to start with blue again, and I can physically see 3 solutions. 3 solutions is what I'm expecting, and since I can see them, that means that it's 3 real solutions. Again, those x-intercepts. On the second one, I see that I've got a dot here, and then I also have a dot here, but that's another one of those bounces. So remember that that one counts twice. So if we want to talk about this one, we can say that we have an RS, which is a bounce for a repeated solution, and then we're going to add to that 1 place where we cross the x-axis, and so that equals 3 real solutions total. Finally, we have our third case. And in this case, I only see 1 dot, and then we never cross, we never bounce, we never do anything else. So that means that I have 1 real solution, and I have 2 imaginary solutions. Now, whether I have a 3rd degree polynomial, a 5th degree, any type of odd degree, we know that our arrows are pointing down towards negative infinity and up towards positive infinity. So that means that there can never be an odd degreed polynomial that we could draw that doesn't cross the x-axis somewhere. So we are always with a odd degree going to have at least 1 real solution. Others could be imaginary, all of the others could be imaginary, but we have to at least have 1 real. And remember, imaginary solutions come in pairs. One other thing to note is what is called a turning point. Remember, we talked about turning points on the front of this foldable, And the number of turning points is going to be at most n minus 1. So notice that for my third degree function, I have 1, 2 turning points, 1, 2, 1, 2. For my second degree function, I only have 1. So whatever the degree is, subtract 1, and that's the most that you can have.